Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 22 on complex analysis and it is the continuation of the last video. Students, in my last video I was explaining Taylor's theorem and in this video I'm going to solve some numerical problems by using Taylor's theorem. But before solving numerical problems, I want to mention some important points regarding Taylor's theorem. Point number 1. Students, this Taylor's series expansion can be done two different ways. Number 1, by using definition, and second one is by using binomial series expansion method. Point number 2, if we expand f of z in Taylor series about some point z equal to a, then the series will contain the powers of z minus a only. Next, some standard expansions. Students, one important point is that all these three expansions are valid for modulus of x less than 1 only. Number 1, 1 plus x whole to the power n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube plus dot dot dot. Number 2, 1 plus x whole to the power minus 1 is 1 minus x plus x square minus x cube plus x to the power 4 minus x to the power 5 plus dot dot dot. So here the value of n is minus 1. Third expansion, 1 minus x whole to the power minus 1 is 1 plus x square plus x cube plus x to the power 4 plus x to the power 5 plus dot dot dot. Now let me solve the numerical problems. Problem number 1. Expand f of z is equal to cos z about z equal to pi by 4 in Taylor series. Students, we will expand this function f of z is equal to cos z with the help of definition only. We know, according to definition, we can expand any function f of z about z equal to a in this way. F of z is equal to f of a plus f prime a into z minus a plus f double prime a divided by 2 factorial into z minus a whole square plus f triple prime a divided by 3 factorial into z minus a whole cube plus dot dot dot. Now let us expand this function about z equal to pi by 4. So here f of z can be expanded about z equal to pi by 4 in this way. F of pi by 4 plus f prime pi by 4 into z minus pi by 4 plus f double prime pi by 4 divided by 2 factorial into z minus pi by 4 whole square plus f triple prime pi by 4 divided by 3 factorial into z minus pi by 4 whole cube plus dot dot dot. Now let us find out the values of f pi by 4, f prime pi by 4, f double prime pi by 4, f triple prime pi by 4, etc. First let us find out this value. We know f of z equal to cos z. So therefore f of pi by 4 will be 1 by root 2. So first term will be 1 by root 2 plus f prime pi by 4. Since f of z equal to cos z, so therefore f prime z will be minus sin z. So therefore f prime pi by 4 will be minus 1 by root 2. So the value of this term is minus 1 by root 2 minus 1 by root 2 into z minus pi by 4. Now let us find out the value of f double prime pi by 4. Students, since f prime z is equal to minus sin z, so therefore f double prime z will be minus cos z. So therefore f double prime pi by 4 will be minus 1 by root 2. Now let us substitute the value of f double prime pi by 4 here. So finally we will get 1 by 2 factorial means 2 root 2 into z minus pi by 4 whole square plus again let us find out the value of f triple prime pi by 4. Since f double prime z is equal to minus cos z. So therefore f triple prime z will be sin z. So f triple prime pi by 4 will be 1 by root 2. Again let us substitute the value of f triple prime pi by 4 here. So finally we will get 3 factorial means 6. So finally we will get 1 by 6 root 2 into z minus pi by 4 whole cube plus dot dot dot. So this is the Taylor series expansion, which is the required expansion. Next, let me solve the second problem. Second problem says expand f of z is equal to cos hyperbolic z about z equal to pi iota in Taylor series. Again, this function f of z will be expanded with the help of definition only. Now let us solve. Here we can expand this function f of z about z equal to pi iota in this way: f of pi iota plus f prime pi iota into z minus pi iota plus f double prime pi iota divided by 2 factorial into z minus pi iota whole square plus f triple prime pi iota divided by 3 factorial z minus pi iota whole cube plus f to the power 4 pi iota divided by 4 factorial into z minus pi iota whole to the power 4 plus dot dot dot. Now let us find out the values of f of pi iota, f prime pi iota, f double prime pi iota, f triple prime pi iota and f to the power 4 pi iota. Since f of z is equal to cos hyperbolic z, so therefore f of pi iota will be cos hyperbolic pi I, and cos hyperbolic pi iota will be cos pi, whose value is minus 1. So the value of first term will be minus 1. Next, f prime pi iota. Since f of z is equal to cos hyperbolic z, so therefore f prime z will be sin hyperbolic z, and f prime pi iota will be sin hyperbolic pi iota, and sin hyperbolic pi iota will be iota sin pi. Since sin pi value is 0, so therefore f prime pi iota will be equal to 0. So the second term will be 0. Third term, f double prime pi iota value is minus 1. So minus 1 divided by 2 factorial means 2, 1 by 2 z minus pi iota whole square plus similarly f triple prime pi iota value is 0. So the value of this term will be 0. Again f to the power 4 pi iota value will be minus 1. Minus 1 divided by 4 factorial. 4 factorial value is 24. So the value of this term will be 1 by 24 z minus pi iota whole to the power 4 plus dot dot dot. So finally we will get f of z is equal to cos hyperbolic z will be equal to minus 1 minus 1 by 2 z minus pi iota whole square minus 1 by 24 z minus pi iota whole to the power 4 plus dot dot dot, which is the required Taylor series expansion, which is the required Taylor's series expansion. Now let me solve problem number 3. According to problem number 3, we have to expand f of z is equal to 1 by z about z equal to 1 in Taylor series. Students, we can expand this function f of z is equal to 1 by z with the help of definition as well as with the help of binomial series expansion method. If we expand with the help of method number 1 or method number 2, we will get the same result. First, let me expand this function with the help of definition. So, method number 1. Method number 1. We know we can expand the function f of z about z equal to 1 in this way. F of 1 plus f prime 1 into z minus 1 plus f double prime 1 divided by 2 factorial into z minus 1 whole square plus f triple prime 1 divided by 3 factorial into z minus 1 whole cube plus dot dot dot. Now let us find out the values of f of 1, f prime 1, f double prime 1, f triple prime 1, etc. We know f of z is equal to 1 by z. So, f of 1 will be equal to 1. So, the value of this term is 1. Now, let us find out the value of f prime 1. Since f of z is equal to 1 by z, so f prime z will be minus 1 by z square. So, therefore, f prime 1 will be minus 1. So, after substituting the value of f prime 1, we will get minus z minus 1 plus. Again, let us find out the value of f double prime 1. Since f prime z is equal to minus 1 by z square, so f double prime z will be 2 divided by z cube. So, therefore, f double prime 1 will be 2. So, 2 divided by 2 factorial means 2, z minus 1 whole square. Next, f triple prime 1. Since f double prime z is equal to 2 divided by z cube, so f triple prime z will be minus 6 by z to the power 4. So, f triple prime 1 will be minus 6. Let us substitute the value of f triple prime 1 here. So, we will get 6 divided by 3 factorial means 6 into z minus 1 whole cube plus dot dot dot. So, after simplifying, finally, we will get 1 minus z minus 1 plus z minus 1 whole square minus z minus 1 whole cube plus dot dot dot, which is the required Taylor's series expansion. Next, let me expand this function f of z equal to 1 by z about z equal to 1 by using second method. So, method number 2. Method 2. Given f of z is equal to 1 by z. Since we need to expand this function about z equal to 1, so the expansion should contain the powers of z minus 1 only. So, first let us rearrange this denominator. So, this denominator can be written as 1 by z minus 1 plus 1. Now, this part can be written as 1 plus z minus 1 whole to the power minus 1. Now, let us use the binomial expansion theorem formula. So, 1 plus x whole to the power minus 1 will be 1 minus z minus 1 plus z minus 1 whole square minus z minus 1 whole cube plus dot dot dot. So, we have seen that we are getting the same result, which is the required Taylor's series expansion. Next, let me solve problem number 4. According to problem number 4, expand f of z is equal to 1 by z minus 3 into z minus 4 about z equal to 2 in Taylor series. Students, we can expand this function f of z is equal to 1 by z minus 3 into z minus 4 with the help of definition as well as with the help of binomial series expansion method. But I will prefer this method only. Okay? Again, since we need to expand this function about z equal to 2, so therefore this expansion will contain the powers of z minus 2 only. Now let me solve. Given f of z is equal to 1 by z minus 3 into z minus 4. Now, with the help of partial fraction method, this term can be written as minus 1 by z minus 3 plus 1 by z minus 4. Now, let me rearrange these denominators so that we will get a series that contains the power of z minus 2 only. So, we can write minus 1 divided by z minus 2 minus 1 plus 1 by z minus 2 minus 2. Next, our target is to convert this term and this term either to this form or to this form. So, let us do. Minus 1 divided by, let us take minus 1 common from the denominator, then we will get minus 1 into 1 minus z minus 2 plus 1 by, again let us take minus 2 common from this denominator. So, finally, we will get minus 2 1 minus z minus 2 divided by 2 bracket close. So, finally, this term can be written as 1 minus z minus 2 whole to the power minus 1 minus half into 1 minus z minus 2 divided by 2 whole to the power minus 1. Now, let me expand this term and this term with the help of binomial theorem. So, finally, we will get f of z is equal to 1 minus x whole to the power minus 1. So, 1 plus z minus 2 plus z minus 2 whole square plus z minus 2 whole cube plus dot dot dot. Again, if we expand this term, then we will get minus half into 1 plus z minus 2 divided by 2 plus z minus 2 divided by 2 whole square plus z minus 2 divided by 2 whole cube plus dot dot dot. Now, let us simplify this term and this term. So, finally, we will get 1 minus half. So total value is half. Again, if we add this term and this term, we will get plus 1 minus 1 by 4. So 3 by 4 into z minus 2 plus. Again, if we add this term and this term, finally we will get 8 to 7 by 8 z minus 2 whole square plus. Again, if we add this term and this term, finally we will get 16. So 15 by 16 z minus 2 whole cube plus dot dot dot. So this is the required Taylor series expansion, which is the required Taylor's series expansion. So this is all about today's video, and I hope that you have learned a lot from this video.